Hello everybody. After learning how to do aggregate plans, let us now learn how to do master schedule. I see someone wonder what is master schedule? And why should we do it? If you know the answer of these two questions and need to know how to make a master schedule, move to the 4th minute of the video. Let me answer the second question first. For the production plan to be translated into meaningful terms for production, it is necessary to disaggregate the aggregate plan. This means breaking down the aggregate plan into specific product requirements in order to determine labor requirements, skills, size of workforce, materials, and inventory requirements. For example, a lawnmower manufacturer may have an aggregate plan that calls for 200 riding mowers in January, 300 in February, and 400 in March. That company may produce 3 different models of riding mowers. Although all the mowers probably contain some of the same parts and involve some similar or identical operations for fabrication and assembly, there would be some differences in the materials, parts, and operations that each type requires. Hence, the 200, 300, and 400 aggregate lawn mowers to be produced during those 3 months must be translated into specific numbers of mowers of each model prior to actually purchasing the appropriate materials and parts, scheduling operations, and planning inventory requirements. While the answer of the second question, which is what is master schedule, is the result of disaggregating the aggregate plan, is a master production schedule or simply master schedule, showing the quantity and timing of specific end items for a scheduled horizon, which often covers about 6 to 8 weeks ahead. A master schedule shows the planned output for individual products rather than an entire product group, along with the timing of production. The master schedule contains important information for marketing as well as for production. It reveals when orders are scheduled for production and when completed orders are to be shipped. The master schedule is the heart of production planning and control. It determines the quantities needed to meet demand from all sources, and governs key decisions and activities throughout the organization. The master schedule interfaces with marketing, capacity planning, production planning, and distribution planning. The master schedule also drives the material requirements planning system that will be discussed later. To make a master schedule, 3 inputs are required. These are beginning inventory, forecast, and customers' orders. While its outputs are projected inventory of finished products, master production schedule, and uncommitted inventory. We will refer to uncommitted inventory by available to promise or ATP. Let us understand master schedule by solving an example. A company that makes industrial pumps wants to prepare a master production schedule for June and July. Marketing has forecasted demand of 120 pumps for June and 160 pumps for July. These have been evenly distributed over the 4 weeks in each month, 30 per week in June and 40 per week in July. The beginning inventory is 64 pumps. And there are customer orders that have been committed or booked and must be filled. So, the shown table contains the 3 primary inputs to the master scheduling process: the beginning inventory, the forecast, and the customer orders that have been booked or committed. This information is necessary to determine 3 quantities: the projected on-hand inventory, the master production schedule, and the uncommitted inventory or the ATP. The first step is to calculate the projected on-hand inventory, 1 week at a time, until it falls below a specified limit. In this example, the specified limit will be 0. Hence, we will continue until the projected on-hand ending inventory becomes negative. The projected on-hand inventory is calculated as follows. Projected on-hand inventory equals inventory from previous week minus current week's requirements, where the current week's requirements are the larger of forecast and customer orders. For the first week, projected on-hand inventory equals beginning inventory minus the larger of forecast and customer orders. Because customer orders are larger than the forecast, the customer orders amount is used. Thus, for the first week, we obtain projected on-hand inventory equals 64 minus 33 equals 31. For the second week, projected on-hand inventory equals projected on-hand inventory of week 1 minus the larger of forecast and customer orders. Because forecast is larger than the customer orders, the forecast amount is used. Thus, for the second week, we obtain projected on-hand inventory equals 31 minus 30 equals 1. For week 3, projected on-hand inventory equals projected on-hand inventory of week 2 minus the larger of forecast and customer orders. Because forecast is larger than the customer orders, the forecast amount is used. Thus, for the third week, we obtain projected on-hand inventory equals 1 minus 30 equals negative 29. When the projected on-hand inventory becomes negative, this is a signal that production is needed to refill the inventory. Hence, a negative projected on-hand inventory will require planned production. Suppose a production lot size of 70 pumps is used, so that whenever production is called for, 70 pumps will be produced. The determination of lot size is in different video. Hence, the negative projected on-hand inventory in the third week will require production of 70 pumps, which will meet the projected shortfall of 29 pumps and leave 41 pumps for future demand. Continue in the same way for the remaining 5 weeks. For week 4, projected on-hand inventory equals projected on-hand inventory of week 3 minus the larger of forecast and customer orders. Because forecast is larger than the customer orders, the forecast amount is used. Thus, for the fourth week, we obtain projected on-hand inventory equals 41 minus 30 equals 11. For the fifth week, projected on-hand inventory equals projected on-hand inventory of week 4 minus the larger of forecast and customer orders. Because forecast is larger than the customer orders, the forecast amount is used. Thus, for week 5, we obtain projected on-hand inventory equals 11 minus 40 equals negative 29. Again, the negative projected on-hand inventory in the fifth week will require production of 70 pumps, which will meet the projected shortfall of 29 pumps and leave 41 pumps for future demand. For week 6, projected on-hand inventory equals projected on-hand inventory of week 5 minus the forecast since there is no customer orders. Thus, for week 6, we obtain projected on-hand inventory equals 41 minus 40 equals 1. For week 7, projected on-hand inventory equals projected on-hand inventory of week 6 minus the forecast as there is no customer orders. Thus, for week 7, we obtain projected on-hand inventory equals 1 minus 40 equals negative 39. The negative projected on-hand inventory in the seventh week will require production of 70 pumps, which will meet the projected shortfall of 39 pumps and leave 31 pumps for future demand. For the last week 8, projected on-hand inventory equals projected on-hand inventory of week 7 minus the forecast because there is no customer orders. Thus, for week 8, we obtain projected on-hand inventory equals 31 minus 40 equals negative 9. The negative projected on-hand inventory in week 8 will require production of 70 pumps, which will meet the projected shortfall of 9 pumps and leave 61 pumps for future demand. Now the projected on-hand inventory and the production master schedule are known. So, it is now possible to determine the amount of inventory that is uncommitted and, hence, available to promise. Several methods are used in practice. The one we will employ involves a look-ahead procedure. Some booked customer orders week by week until, but not including, a week in which there is an MPS amount. For example, in the first week, this procedure results in summing customer orders of 33, in week 1, and 20, in week 2, to obtain 53. In the first week, this amount is subtracted from the beginning inventory of 64 pumps to obtain the amount that is available to promise. Thus, 64 minus the summation of 33 and 20 equals 11. This inventory is uncommitted, and it can be delivered in either week 1 or 2, or part can be delivered in week 1 and part in week 2. Note that the ADP quantity is only calculated for the first week and for other weeks in which there is an MPS quantity. Hence, it is calculated for weeks 1, 3, 5, 7, 8. For weeks other than the first week, the beginning inventory drops out of the computation, and ADP is the look-ahead quantity subtracted from the MPS quantity. Thus, for week 3, the promised amounts are 10 plus 4 equals 14, and the ATP is 70 minus 14 equals 56. For week 5, customer orders are 2 only as future orders have not yet been booked. The ATP is 70 minus 2 equals 68. For weeks 7 and 8, there are no customer orders, so for the present, all of the MPS amount is available to promise. As additional orders are booked, these would be entered in the schedule, and the ATP amounts would be updated to reflect those orders. Marketing can use the ATP amounts to provide realistic delivery dates to customers. Hopefully, you can make the master schedule by yourself. If you like this video, so press like and share it. And do not forget to subscribe to the channel and activate the alarm to be notified of the new videos. Goodbye.